Hey Elon, you need some help landing the Starship?
Yeah.
Well, check this out.
I was very sad to see that.
Worth a try. What's happening, guys? My name's Nicholas Renaud, and in this video, we're going to be going through reinforcement learning for beginners. And who knows, along the way, we might even help Elon out. Let's take a deeper look as to what we'll be going through. So in this video, we're going to be covering three key things. So first up, we're going to start out by installing the Stable Baselines package. So this is going to be a package that makes it a whole heap easier to get started with reinforcement learning. Then what we're going to do is we're going to set up the OpenAI Gym Lunar Lander environment. So this allows us to build a model that allows us to actually try to land a spaceship on the surface of the moon. So we're actually going to try to build an AI model, and specifically a reinforcement learning model that's able to land that spaceship successfully. Then what we're going to do is once we've gone and built that model and trained it up, we're going to test it out and run it, and you'll be able to see how our AI performs in real time. Let's take a look as to how this is all going to fit together. So first up, what we're going to be doing is we're going to be setting up our Lunar Lander environment, and you can see on the slide, this is a little spaceship that we're going to be trying to land between the flags. So the main goal is that we'll have our lander sort of pop up onto the screen, and the goal is to direct the jets on that particular lunar lander so that we're able to land it successfully within those flags. So if our AI and our reinforcement learning model is able to do that, then we've completed the task successfully. So in order to do that, we're going to be training a reinforcement learning model from the Stable Baselines package, and we'll go through setting all that up. Once we've trained it, then we'll unleash our reinforcement learning model on the Lunar Lander environment, so hopefully we can land it between those flags. Ready to do it? Let's get to it. Alrighty, so in order to kick off our reinforcement learning for beginners tutorial, there's going to be 4 key things that we need to do. So first up, what we're going to need to do is install and import our dependencies. Then what we're going to do is test out our environment. So specifically, we're going to be passing through random actions to our environment there. So if you've seen the reinforcement learning crash course video that I did, again, link will be in the description below. You'll see how we wrote this code, but as always, all the code that we write in this particular video is going to be available in the description below via my GitHub account. So once we've tested out our environment, what we're then going to do is build and train our model. And this is going to be where we use some of the algorithms from Stable Baselines to actually go on ahead and train a reinforcement learning agent. Then last but not least, we'll save and test it out. So we'll actually be able to see our Lunar Lander model actually working in real time. Now on that note, so our core dependencies are going to be Stable Baselines. So Stable Baselines is just a ridiculously useful reinforcement learning library that has some really good algorithms available in it. So if you actually scroll on down, go to stable-baselines.readthedocs.io, you'll be able to access this documentation. But again, this link will be in the description below. You'll see that we've got a whole bunch of RL algorithms that we can work on. So we're going to be working with ACER, but PPO2, I've had really good results with that, and A2C as well. The other dependency that we're going to be working with is OpenAI Gym. So this is obviously one of the most popular libraries when it comes to reinforcement learning environments. And the environment that we're going to be working with is Lunar Lander. So you can see that we've got this little spaceship that's trying to land just in general, but also in between these flags. So if you land within the flags, then you get more points. But ideally the goal is to take this little purple spaceship that you can see here and get it to land successfully without breaking its little legs. So what we're going to do is we're going to be trying to build a reinforcement learning agent to be able to solve that problem. And we're going to approach this in a reasonably straightforward manner. So we're going to leverage Stable Baselines to help us to do that. Alrighty, without further ado, let's first go on ahead and install and import our dependencies. So I'm going to write the line of code, and then we'll take a step back and we'll take a look at what we've got. Alrighty, so before we go on ahead and run that, let's take a look at the code that we've actually written. So first up, we've got exclamation mark. Let's just make sure this is zoomed in. Perfect, cool. So we've got exclamation mark pip install TensorFlow equals 1.15.0. This is a key thing to note. So if you're working with Stable Baselines, you need to be using a TensorFlow version, which is before TensorFlow 2.0. So ideally, what you want to be doing is using 1.15. So what we've got here in this line is we're going to install TensorFlow 1.15.0 and TensorFlow GPU 1.15.0. And to do that, we've written TensorFlow equals 1.15.0 TensorFlow dash deep GPU equals 1.15.0. So this pip install line is going to go on ahead and install both of those. And this really just covers all bases, whether or not you're using GPU or a non-GPU machine. Then the next package that we're installing is stable_baseline. So this is going to install all of our algorithms that we saw on stable baselines. Then the next thing that we're installing is Gym. So this is OpenAI Gym. And we're also installing box2d-pi. So this is a dependency that you're going to need if you're using the Lunar Lander environment. So we're just going to install it just to make sure our lives remain easy as we're going through this. And then I'm also passing --user. So this is going to use the user flag to install it for me as a user. Just avoids any administrator dependencies if that happens to occur on your machine. So in this case, we're going to hit Shift Enter and run that cell, and that's going to go on ahead and install our dependencies. Now you can see that that's run pretty quickly, and that's because I've already got it installed. So we can go on ahead to our next step, which is importing these dependencies. So let's go on ahead and do that. Alrighty, so those are our dependencies now imported. So what we've done is we've written 4 lines of code there. And specifically what we've gone and imported is OpenAI Gym and then a whole bunch of different dependencies from stable baselines. So our first line of code that we've written is import Gym. So this is going to import OpenAI Gym, and it's going to allow us to create a Lunar Lander environment that we can then apply our reinforcement learning models to. Then what we've gone and written is from stable_baselines import ACER. So this is importing the ACER policy or ACER agent that's going to allow us to train our reinforcement learning agent. So think about this as an algorithm. So similar, if you've done any machine learning before, think of this as a specific machine learning type of algorithm. So in this case, we could also sub out and we could use something like, let's take a look. We could use something like DQN, PPO, DDPG. So think of them as different algorithms. So in this case, we're going to be using ACER, but you could try different ones if you wanted to. Then the next line that we've written is from stable_baselines.common.vec_env import dummy vec env. So this is basically a wrapper that goes around our OpenAI Gym environment that allows us to create a dummy vectorized environment for stable baselines. So when we're working with certain stable baselines algorithms, it's expecting that our OpenAI Gym is vectorized. Now in this case, we're not going to explicitly vectorize our Lunar Lander environment, but instead we're going to wrap it inside of our dummy vec environment. But you'll see that once we go to set that up. And then the last dependency that we've imported is evaluate policy. So to do that, we've written from stable_baselines.common.evaluation import evaluate_policy. And the evaluate policy method just makes it really easy to test out our model and see how it's performing. So we'll use that right in step 3 where we go on ahead and test out our model. All right, so those are our dependencies done. Now what we're going to do is we're going to set up a variable that's going to hold the name of our environment. And in this case, our environment is going to be named Lunar Lander v2, so we can actually just copy that. And we're going to create a new variable called environment name, create an empty string, and then paste that in. So this basically is just going to save us time from writing Lunar Lander -v2 each time we want to create an instance of our environment. Now that's pretty much step 0 done. So we've gone and installed our dependencies. We've also gone and imported a whole bunch of stuff, and we've created our environment variable. Now the next step that we need to go through is to test out our environment. And I've said random environment, but really it is a standard environment. What we're actually doing though is we're actually just going to go and take a bunch of random steps inside that environment. Because if you take a look, you can see that our Lunar Lander is taking random steps here in this particular video on the OpenAI Gym webpage. We're going to try to replicate that just to see what our environment looks like and how it actually operates. So what we can do in order to do that is just run this cell, which is going to use gym.make, and then it's going to pass through our Lunar Lander string here to be able to go ahead and create our environment. So if we run that cell, that's created our environment. Now what we can actually do is we can actually go on ahead and run this block of code. So what it's going to do is it's going to attempt to land our Lunar Lander 3 times. So we've gone and set up episodes equals 3, and this basically means that we're going to try it 3 times to try to land it successfully. We're initially going to reset our environment, set done, and score to false and 0 respectively. So this is just resetting variables. And then what it's going to try to do is actually go on ahead and land it. And specifically, we're only just going to take random steps. So there's no logic or reasoning behind how it's going to land it. It's just going to take random steps. So you see that it won't actually perform that well when we go and run this code. Now, ideally, what should happen is once we finish training our model and we go and apply it in a similar way, we'll actually be able to land our lander more appropriately when it comes to doing that. So let's go on ahead and run this and see how it actually looks like. So I'm going to set it episodes back to 10. So this is going to give us a little time to actually see the pop-up appear at the bottom of our screen. So when you run this, you'll get a little Python pop-up, and this is actually going to be the screen that we're able to see our environment in. So if I run this, you can see we've got our little pop-up. You can see our Lunar Lander right now, it's nowhere near landing. So ideally, our goal is to either land it anywhere. Ideally, we want to land it between these flags, and our model will learn to do that. But right now, it's not even getting close, right? It's crashing each and every single time. And our score isn't getting anywhere into the positive numbers. So those are our goals, right? So we want to be able to land our lander, ideally get it between the 2 flags, and that should mean that our score is no longer in the negatives, but we're now in the positive values. So now that that's done and we've tested out our code, that's step 1 done, or this particular step done. The next thing that we want to go on ahead and do is actually build and train our model. So let's go on ahead and write that code, then we'll take a step back and see what we've written. Alrighty, so we've gone and written 3 lines of code there. And the nice thing about stable baselines is that it makes it reasonably simple to get up and running. So this particular step, you could really skip this testing out of your environment, but it's a good idea to understand how the environment actually operates. These 3 lines here actually create our environment, set up our model, and really, if we wanted to, there's one additional line which we'll do in a sec, which is going to go on ahead and kick off our training to be able to train our reinforcement learning algorithm. So let's take a quick step back and see what we've written here. So first up, we've written env equals gym.make, and then we've passed through our environment name, which we had up here. Then, as I said, what we did is we're going to wrap our environment inside of this dummy vec environment. And our dummy vec environment is actually expecting an environment generator as its input. So what we've done, rather than writing a full-blown function, we've just wrote lambda, and then we're creating a new environment each time we loop through that. So ideally, what you're going to get out of this is a number of environments generated. In this case, it's just going to be 1 because we're only passing it through once. And then we're effectively going to reset our environment variable equal to env. Then what we're doing is we're creating a new instance of our ACER algorithm. And remember, this is the algorithm that we imported up here. And if you wanted to, you could swap this out for any one of these algorithms that you see there. So again, play around with them. You're going to probably get differing results and differing training times depending on which algorithm you use. But in this case, we're going to be using ACER, which you can see here. Then to that algorithm, we've gone and passed 3 key variables. So specifically 2 arguments and 1 keyword argument. So to do that, we've written model equals ACER, and this is our algorithm that we brought in up here. And then we're passing through the policy. So think of this as the neural network that sits behind this algorithm. In this case, we're using a multi-layer perceptron policy. I believe that's what it stands for, but you could just as easily use a CNN policy, which is going to work with image-based environments. You could also use an LSTM-based policy, which is going to give you a recurrent neural network, which is particularly good if you've got sort of time series-based environments or environments that rely on previous states. To that, we're then also passing our environment, which we created over here, and we're setting verbose equal to 1, because this is going to give us a whole bunch of additional information when we kick off our training run. So basically, in a nutshell, creating our environment, wrapping it inside our dummy vec environment, then setting up our model initially. So the next thing that we need to do is actually go on ahead and kick off our training. So let's go on ahead and write that line of code, and we'll see what it looks like. So that's really the last line of code that we need to write to be able to build and train our model. So to do that, what we've written is model model.learn. So this is akin to a fit method, and what it's effectively going to go on ahead and do is kick off our training run. Now to that, we've passed through one keyword argument, which is total underscore time steps. And then to that, we've passed through 100,000. So this basically means that our reinforcement learning model is going to go on ahead and try to train for 100,000 different steps using our Lunar Lander model. So what we can now go on ahead and do is run that cell, and it's going to kick off our training run. Now, if you wanted to, you could train for a shorter amount of time or train for a longer amount of time. But ideally, what we want out of our model is as high as possible explained variance, which we'll see in a sec, and as high as possible mean episode reward. So let's go on ahead and kick this off. I'll show you what the results look like initially, and then we'll let it run and we'll be right back. All right, so that's our model kicked off. So you can see here that as our model runs, we get these little bits of information. And this is because we set verbose equals to 1 up here. Now, as I was saying, what we want out of this is as high as possible explained variance and as high as possible mean episode reward. So right now, our explained variance is not that great. So we've got in the 0.000399, and mean episode reward is currently 0. So ideally, we want our mean episode reward to be in the positive numbers and not negatives, and our explained variance to be as high as possible. So ideally, the closer to the number 1 we get, the better it's going to be. So let's go on ahead and let that run, and we'll be right back. Alrighty, so in the end, what I ended up doing is pausing the training a little bit earlier, as we were already getting reasonably good performance. So ideally, what you want to do is once your model starts performing reasonably well, you don't want to overtrain it, because sometimes what that will mean is that your model starts performing more poorly and starts to overfit the particular environment. So in the end, what we did is we got our explained variance to 0.831, which is pretty good. And we also got our mean episode reward to 122. So this should ideally mean that we're able to successfully land our lunar rover pretty accurately. So the next thing that we actually want to go and do now that we've gone and trained our model is we actually want to go on ahead and test it out. And this is where the evaluate policy method comes in. So what we're now going to go on ahead and do is go on ahead and test out our evaluate policy method. So the other thing also to note when you're running model.learn is you can also run a callback. So this will allow you to go on ahead and automatically pause your training once you sort of get to the optimal level. If you'd like to see a video on that, by all means, leave a mention in the comments below and I'll get to it. So the next thing that we're going to do is now run evaluate policy. So let's go on ahead and write that learner code and see how our model is actually performing. Okay, so before we run that, let's take a look at our code as usual. So what we've gone and written is evaluate underscore policy. So this is using our evaluate policy method that we brought in up here in our imports. And then to that, we're passing through 2 arguments and 2 keyword arguments. So specifically, we're passing through our model, our environment, which we defined earlier. We're then defining how many evaluation episodes we want to run through. So that this is how many chances we want to give our model to be able to prove its performance. In this case, we're setting that to 10, and we're specifying render equals true because we want to visualize our performance and our results. So what we should effectively see is our AI or our reinforcement learning model trying to land our lunar lander. And then we're running env.close to be able to close it off. So let's go on ahead and run this line of code and let's see our performance. So again, we should get the little pop-up down below, and you can see our model is attempting to land our lander. And there you go, so it's landed successfully, and you can see it's now more accurately adjusting each one of those boosters to be able to go on ahead and land our lander between the flags. So that's 2 successful landings now. So as you can see, it's performing pretty well, even though we didn't hit the elusive 0.99 explained variance and ridiculously high accuracy or ridiculously high mean episode reward. You can see that we're still getting there. In this case, it's trying to push the booster to try to get it between the flags. But in this case, it's performing a lot better once it's adjusting while it's still in the sky. So you can see this one's obviously performing really well. It's getting quite close. Come on. Yes, all right. Elon, come on, you got to come and hire us now. So again. Pretty cool, right? So we're performing reasonably well. Not quite Falcon heavy, but we're getting there, right? And so again, we've done this on Lunar Lander, but you could try this out. Obviously, we had a last minute crash landing there, but you can see that obviously our reinforcement learning model is performing a lot better than what we had when we were just going and running our random environment up here. So now that that's all done, the next thing that we want to do is go on ahead and save our model. So again, this is all part of a good data science workflow. You want to be able to reload your model and try it out, particularly if you wanted to go and deploy this into production later on. So let's go on ahead and save our model. So to do that, we can just write model.save, and then in this case, just name it whatever you'd like. So we'll call it ACER _model. If we now go into the same folder as our Jupyter notebook, you can see that it has in fact saved. So this is our ACER model here. We can now delete our model. If we try running our model, you can see it's not going to work. And then we can reload it. So that, again, this is all to do with being able to reuse your model later on. So to do that, we can just type in model.load and then copy this. And we also need to pass through our environment when we're reloading it. Sorry, ACER.load. So again, it's our algorithm that we're going to use, .load, and then the name of the model that we save. So to be able to save it, it's model.save. To reload, name of the algorithm, .load. So in this case, this should reload our model, which again, we've now reloaded. We'll just store it inside of a variable called model equals. And now we can actually start testing this out again. So rather than using evaluate policy this time, I'm going to write out a little bit of a flow which sort of closely mimics this, and really ideally mimics how you might put this into production, particularly if you've got sensors on a particular environment. So let's go on ahead and write this and see how our model performs there. Okay, so that's our last bit of code done. Now, before we go on ahead and run that, let's take a look at what we've written. So first up, what we've gone and done is we've gone and reset our environment. So whenever we're going out and testing our new code or testing out our RL model, we want to reset our environment back to its base state. And this is exactly what this line is doing here. Then what we're doing is out of that base state, we're capturing those observations inside of a variable called OBS. And so the full line is OBS equals env.reset. And then we're going through and kicking off a loop. So this is basically just going to keep running different instances of our Lunar Lander environment multiple times. So we'll actually have to force stop this if we want it to stop running. So we've written while true and then with a colon. And then what we're doing is we're using our model that we've trained up here, and we're using the predict method to go and generate an action based on the observations from our environment space. So think about this as our model receiving the inputs from our Lunar Lander environment, then trying to predict what the best action should be to be able to land our rover successfully. And out of that, what we're going to get is the most appropriate type of action and the current state of our model. So what we're then going to go on ahead and do is apply that action to our environment, which you can see there based on env.step. So we're going to our environment, we're taking a step using the action that our model has just predicted. And out of that, we're going to get new observations, rewards, whether or not our particular episode is done, and any additional info. And then we're going to render the current frame. So this will allow us to see how our model is performing in real time. So let's go on ahead and run this, and then eventually we'll have to kill it off to stop it running, and we can then close it. So again, it should look pretty similar to our evaluate policy, except this time it's just going to keep running. So let's kick it off. And again, it's opened up our window, and it's going to try to land our lander. And again, working pretty successfully. You can see that it's landed and it's just going to restart. So this is just a slightly different way to go on ahead and kick off your code. Again, that's another successful landing. Again, it's looking like it's performing reasonably well now. Alrighty, and we'll stop that there. And if we wanted to, you can see that our little icon is still open. So to close that, we can just type in env.close. And that will close the little pop-up there so that you can then go on ahead and kick off evaluate policy or that whole loop all over again. And that about wraps it up. So what we've now gone and done is we've gone and installed and imported our dependency. We've gone and tested out our random environment. And again, all this code is going to be available inside of the description below. Just check that out. You'll be able to grab it. So on step 2, we built and trained our model, and really these 4 core lines were the core components to actually go on ahead, build our environment, and train our reinforcement learning model. We then went and saved and tested it out, and we tested it using the evaluate policy method, and we also wrote our own custom code to go on ahead and test it out. And that about wraps it up. Thanks so much for tuning in, guys. Hopefully you found this video useful. If you did, be sure to give it a thumbs up, hit subscribe, and tick that bell for more awesome reinforcement learning content. And let me know how you went about building your own reinforcement learning model. Thanks again for tuning in. Peace.